Hello everyone, as part of learning the Hadoop framework, we were looking at Sqoop. So let us see some of the topics related to Sqoop import and a brief look at Sqoop export. So coming to imports and consistency. In the previous sessions we have seen how the import operation is executed and how we are getting data from RDBMS, a structural RDBMS or structural databases into HDFS. Import is from the external database sources, we are trying to get the data into HDFS into the form of text files, that is import operation. Now during the import operation, how do we ensure the consistency? Where does the question of consistency comes is, suppose we have the original data in Oracle SQL, Oracle database or SQL database. When the import operation is happening, we should not allow anyone to update the corresponding table in the database, just to make sure inconsistent data is not entering into HDFS. So during import operation, the essence of this is, how do we ensure consistency is when somebody is trying to import data from, say for example, a student table. When I am trying to import data from student table into HDFS, I should not allow any other user to do any updates on the student table. This ceasing of updates until the import is completed helps us to ensure consistency during import operation. Just go through that quickly. When importing the data into HDFS, we need to ensure access to a consistent snapshot of the source data. The best way to do this is to ensure that any processes which are updating the existing rows of a table should be disabled until the import operation is completed. This is how Sqoop and the databases will try to ensure the consistency during the import operation. Now, there is something called as incremental import. What do we mean by incremental import? I will just deal this with an example. Say for example, I have my student table with some 100 records, and today I performed a Sqoop import. All the 100 records of that student table have been brought into a file in HDFS. I finished the import operation. Tomorrow, say for example, 20 more rows will be added into the student table. So in such case, how do I ensure that those 20 records are also brought into HDFS? Because I want all my student records to be brought into HDFS. Today I could finish importing the 100 records which are there in the file, which are there in the table. Maybe tomorrow, say for example 50 more students or 20 more students are joining the institution and their records should be brought into the HDFS. What will happen? So whenever the table gets updated, getting those records into HDFS is called as incremental import. This incremental import can be done in two ways. First method is the append method, second method is last modified. What do I mean by append method? In the append method, what we do is we try to mark something called as last value. There is a variable wherein we try to mark it as last value, which will tell me what was the last value of a specific column in the table. Generally, this column will be the primary key. Say for example, I had imported the student records from roll number 1 to roll number 100. What was the last value of roll number which I have brought into HDFS? In my example, it is 100, right? So generally we select the primary key and what was the last value of the primary key that was brought into HDFS. We mark it in a variable, system variable called as last value. So whenever you are trying to go for append method, from after 100 whatever new records are there, then those records should be brought and appended to the text file which we have already got in HDFS. This method of updating the file with the extended data in the table using the last value of a primary key, and this method is called as the append mode of incremental import. The second one is last modified. This one will be when was the last time the table was modified. Whenever we are trying to insert rows or update the table, with every update operation, it could be inserting a new row or it could be updating an existing record value. In such case, we maintain, with respect to the updates, we maintain a column called last modified. The timestamp will be maintained. Now, whenever you are trying to do the incremental import, it will compare the import timestamp with last modified timestamp. Suppose the last modified one is the recent one, you try to get those records back into HDFS file. That is how we are trying to make sure the HDFS file which is obtained from the relational tables is up to date and it is consistent, right. So, just go through incremental imports, which is very important to understand how we are ensuring the consistency via the two methods, append and last modified. Append method will take care of getting the records which are newly inserted into the table, whereas last modified will help me to know the records whose values, field values have been modified using the update operation in the relational databases. So, in either case we are trying to get the data into HDFS and add it to the existing file. We call this process as incremental imports. Then there is something called as direct mode import. What do we mean by direct mode import? Generally, whenever we are working with import, Sqoop issues JDBC connectivity with the RDBMS and tries to get the data and put them into the text file. But some of the databases, they provide built-in APIs which does not need a JDBC connectivity, but they just provide us the dump of the database. For example, MySQL will provide a dump called MySQL dump, which will allow Sqoop directly to retrieve data from the table and import it into HDFS. There is no need of JDBC connectivity, all those things. Similarly, majority of the RDBMS, they have their own built-in routines which will help in order to get the data. So, without JDBC connectivity, if you are trying to get the data from the RDBMS or external databases into Sqoop via the import, we call such kind of imports as direct mode import. If you do not want to work with those built-in APIs of the database systems, definitely we have a way of working with JDBC connectivity, which is built into Sqoop. Also, once we are trying to import the data, what type of work can we do? Whenever we are trying to work with whenever we are trying to import the data, you can try to do various types of works. You can get the data into a text file, do whatever operations you want, do whatever analysis you want. Once you finish that, you can send the data back to RDBMS. We call this operation of getting data from an RDBMS table into HDFS, we are calling it as import. Once I finish my work, I want to send the data from HDFS back into the structured store. We call it as export operation. So, we can definitely do the job of exporting also. So, this process of doing import and export can happen via Sqoop and Hive in a 3-step process. First one is importing data into HDFS. Second one, you create a Hive table. Then once you finish the work with whatever data you are trying to import, load the data into HDFS resident data into Hive. So, I will just show you how are we trying to work with Sqoop and Hive. Is first consider, suppose I have a log record on a file called widgets. This is the data which consists of a widget ID, and how much quantity of widgets, then the shipping address and the order date, just like a purchase record. Try to consider this kind of data is there. How are we importing this data into Hive? Before importing, see, actually I need to import the data into HDFS, create a Hive table, then I want to load the data which is there in HDFS, I want to load it into Hive. How are we doing that? In order to load data into Hive, Hive again stores the data in the form of tables. So first let us create a table in Hive using the same syntax similar to MySQL syntax, wherein we are creating a table with the attributes widget ID, quantity, address and sales date or order date. After you give this command and say, the table will be created. Once the table is created, whatever data we have in this particular file, we want to load it into the table called sales. So the HDFS resident data is being loaded into the Hive table. After that, what are we trying to do? Just go through this one. What are we trying to do? The data from HDFS resident will be stored into the table. Just go through this one. Sqoop, create Hive table, connect via JDBC. What is the table? Widgets. So from this text file, try to put it into the file. What is the file name? We are trying to load the widgets data into the widgets table. So whatever sales data you have, you are trying to put it back into Hive table. This entire 3-step process, what is the 3-step process we have done so far? We have imported the data into HDFS, we have created a Hive table, and a HDFS resident data has been loaded into Hive. This 3-step process can be done in a single step. What is the single step? Sqoop, import, connect JDBC. To the database is Hadoop guide. What is the table? Widgets. Use a mapper 1, by default it will be 4. You are ensuring the data is pretty small, so only one mapper is enough. And what it has to work? Hive import should be working. So this entire 3-step process can be simplified and it can be done in a single step. So what exactly we are trying to do here is, the data which you are trying to get from external sources into HDFS can be given to multiple frameworks of big data Hadoop, wherein you are trying to work the data in multiple ways. I can use it for importing using Sqoop, I can analyze my data, I can put it into the warehouse using Hive. So various things can be done. And whenever you are trying to import data from RDBMS systems, we definitely get a situation wherein you might encounter some large objects. So how do big data or Hadoop systems or Sqoop, they deal with large objects? Whenever we are trying to work with RDBMS, we might have specific types of large objects, character large objects and binary large objects. Such large objects, whenever they are read via Sqoop, they will be stored into a file called as LOB file, stands for large object file. These files, they can store huge amounts of large object records. But if the large objects are less than 16 MB, they are maintained in line with the rest of the data. If the large object's size is more than 16 MB, then only they are maintained in a separate file called as large object file. And so far, this is what we were doing with importing the data. Now what exactly is export? In Sqoop, import refers to movement of data from database system to HDFS. What is the contrast operation? That is the export, which uses HDFS as the source of the data. Now where is my data existing? It is in HDFS. That data should be sent to a remote destination as the destination, remote database as a destination. Now how are we going to export the data? We can export the results of this analysis into a database for consumption by the organization or by data analysts, whoever is concerned with the results. Before exporting a table from HDFS to a database, we must prepare the database to receive the data by creating a target table. Naturally, when the data is coming from HDFS into RDBMS, the RDBMS must be ready with the table schema definition in order to hold the data. Now from HDFS I am sending it as a plain text file. The RDBMS has to break the fields at the delimiters, discard the delimiter, do the type conversions of the field values. All such things should happen internally before the RDBMS receives the data. All these are done or taken care exclusively by the JDBC APIs. They will take care of all these things. They parse the text file row, they discard the delimiters, and they try to do the type conversions of the data, and they also try to make the data ready to be accepted with the delimiters of the database. So say for example, we are trying to export a file called zip_profits, a table from Hive. What should I do in MySQL? Create table sales by zip code. What is the volume of sales and what is the zip code. The table is created, and how do I export? Just go through this command once. How are we exporting the data? Sqoop, export, connect the JDBC to MySQL, and what is the database we are working with? Hadoop guide with a map function 1 or with MapReduce 1. What is the table? Sales by zip code. Export the data from which HDFS file? You are mentioning that. And what are the fields that are terminated in the file with what separator? What is the delimiter in the text file? That you are mentioning. Sometimes it could be a comma, sometimes it could be some other symbol, various delimiters could be there. For every delimiter you can specify an escape character. I will show you the escape characters that are available. I will show them the escape characters, but just if you see this one, the data which is there in the text file was brought, understood by the API, and it was made ready to be stored into a table, all by this single command. Once the data is stored into the table, how do I access my data? Simply by using the MySQL command, I can see the data which is stored into the table. So from a HDFS file, you are trying to bring data into a table, which we are calling it as an export operation. So the default delimiter here, what we have seen is \0001. This is the default separator we have seen. There are multiple separators which are available. Suppose backspace you want to work with, the \B is there. New line sequences. Text files are terminating with a new line sequence. Whenever the line terminates, there is a new line sequence. So whenever you want to work with the escape sequence, these are the escape sequences that are available, which are understood by the APIs, which are trying to bring the data from HDFS into tables or RDBMS. Now just quickly look at the exports in a deeper perspective. Whenever the Sqoop is performing exports, it is just doing them just like it is doing the import operation. But before performing the export operation, Sqoop has to prepare a plan for it. So we call it as Sqoop picks a strategy based on the database connect string, what type of database we are using and what type of preparation does it need in order to export the data. Most of the systems Sqoop uses JDBC, and Sqoop generates a Java class which is needed for say for example I have stored my text file. For example, I have this one, the zip code is there. In a text file it will be maintained like a normal string. The string consists of 10005, but the moment it is brought into the table, I have defined the data type to be an integer. So there should be a method which is converting a string into an integer, a string which is casted to an integer by excluding the double quotes. Whatever value that is there between the double quotes should be treated as a number but not as a string. All such methods are made automatically available whenever it is trying to export the data. So for that there will be so many overloaded methods for parse. There is a method called parse which will have multiple overloading methods for every data type. Then whenever it is exporting from text file, it will read record by record. The moment JDBC is taking care of the data, it will try to put them into a batch, and once a batch of records is prepared, all these set of records are inserted into the table at once, which will try to save the time, and it gives better performance than inserting each row at a time. We are going for batch insertion into the table. So how this is happening, just have a look. The Sqoop client is issuing the export operation. For that it will try to read the metadata of the table. Accordingly it launches the MapReduce code which will take care of parsing the statement, parsing the fields, conversions, everything. And it also uses the record container class matching the table definition, and multiple mappers will try to insert the records into the database table. And whenever we are working with exports, how the transactionality is ensured. Whenever we are trying to work with the export operation, whatever records it is trying to read from the text file, they are not immediately loaded into the actual table, but they are temporarily put into a table called staging table, an intermediary table. Once all the records are successfully exported to staging table, then from the staging table they are loaded into the original table. This is just to ensure either all records have been entered into the table consistently or none of them. So just to ensure the transactionality, export command uses an intermediary table which is called as the staging table. And export and sequence file, whenever we are working with export operation, Sqoop can export records stored in sequence files to an output table too. Normally whenever I was talking about export, I told from HDFS file you are trying to export data into a table in RDBMS, but in reality Sqoop can export records which are stored in sequence files or also can be exported to a table. In such cases, some restrictions are applied because sequence file cannot contain arbitrary record fields, and Sqoop's export tool will read the objects from sequence files and send them directly to the output collector. What the output collector is doing, it will pass the objects to database export output format. And whenever we are trying to work with Sqoop, record must be stored in value portion of the sequence files key value pair format and must be a subclass of org.apache.sqoop.lib.sqoop record abstract class. So whenever you are trying to take data from a text file and exporting it to a table, the process is listed out. When you are trying to take data from a sequence file and exporting it into a table, it has to subclass to this particular org.apache.this class, and also in sequence files the data will be in the form of key value pair. So the entire record information should be in the value portion of the sequence file. So having said all this, Sqoop helps us to work with various types of operations and huge amounts of data from the RDBMS to HDFS and back from HDFS to RDBMS. Thank you.